You've seen it at a Halloween party, or maybe a concert. A big plastic bin full of the stuff, and this thick white fog is just pouring over the sides, crawling along the floor like something alive. You reach in to grab a drink, and the moment your fingers get close, you yank them back, because that cold hits you like a wall. So you watch it instead. And here's the thing that sticks with you. That ice is sitting there, disappearing. No puddle underneath, no wet floor, no melt. It's just going away, getting smaller, vanishing into thin air. And nobody seems to think that's weird. But it is weird. So here's the question. Why doesn't dry ice melt?
To answer that, you have to go back to 1835. A French chemist named Charles Thilorier had spent years obsessing over one of the most abundant gases on Earth, carbon dioxide. Everyone knew CO2 existed. Nobody had figured out how to store it, concentrate it, make it useful. Thilorier built a giant pressurized metal cylinder, basically a bomb by the safety standards of the time, and he pumped CO2 inside at extreme pressure. Then he released the pressure valve. The gas expanded so fast it cooled itself almost instantly, and what he saw shocked him. A white, chalky solid had formed inside the cylinder. Solid carbon dioxide. Something that had never existed outside of laboratory theory.
He touched it. It was colder than anything he'd ever felt. And when he looked back at the cylinder a few minutes later, the solid had almost completely disappeared, without leaving a single drop of liquid behind. That observation, right there in 1835, is the whole story of dry ice.
Here's the best way to think about it. You know how water exists in 3 states? Solid ice, liquid water, and steam. And you know that each one transitions into the next depending on temperature. Heat up ice, it melts into water. Heat up water, it boils into steam. Simple, predictable. That's how most substances behave. Now imagine a road that goes from one city to another, but there's a section in the middle that's completely washed out. You physically cannot drive through it. You have to go around, or you don't go at all.
CO2 has a washed-out road. At normal atmospheric pressure, the pressure of the air around you right now, carbon dioxide cannot exist as a liquid. It's physically impossible. The molecular conditions that would allow CO2 to stay in liquid form require pressure about 5 times higher than what's in this room. So when dry ice warms up, it has no path to liquid. It goes straight from solid to gas. That process has a name: sublimation. Sublimation just means a substance skips the liquid phase entirely and transitions directly from solid to gas. The fog you see? That's not the dry ice itself. Dry ice is invisible as a gas. What you're seeing is the surrounding water vapor in the air getting so cold it condenses into a visible cloud. Basically instant fog, on demand. But here's what nobody tells you. Dry ice doesn't just happen to skip the liquid phase. It is incapable of melting, ever, under any normal conditions. That's not a quirk. It's the law of physics for CO2. Most people assume that if you warmed dry ice up really slowly or carefully or in just the right environment, it would melt like regular ice does. It won't. There is no temperature at which dry ice melts at normal pressure. Not warmer, not colder, not somewhere in between. The liquid phase for CO2 at regular pressure simply does not exist. To get CO2 to behave like water, solid to liquid to gas, you'd need to be inside a sealed, pressurized chamber. Under those conditions, dry ice can melt. Scientists and engineers work with liquid CO2 all the time. But outside of that, in your kitchen, at a party, in a shipping cooler, dry ice has never melted, and it never will. It can only disappear.
Here's what this means for you. Next time you sheep something temperature sensitive, biological samples, certain medications, really good ice cream, dry ice is the better choice over regular ice, precisely because there's no liquid. No melt means no moisture. No moisture means your package doesn't get soaked. And the next time you see that fog rolling off a cooler at a party, you'll know. That's not cold air. That's the atmosphere itself reacting to a substance that simply refuses to exist as a liquid.
If this genuinely changed how you think about something you've seen 100 times, hit like. It directly helps more people find videos like this one. And subscribe if you want the science behind ordinary things explained the way it actually works, not the way it's usually glossed over.